Right, this is section 4.3. In this section, we are going to talk about polynomial division. In the previous two sections, in 4.1 and 4.2, we were graphing polynomial functions. In order to graph them by hand, we would have to look at the leading term of our polynomial, and depending on the leading term, we would know the end behavior of our graph. Another thing from 4.1 and 4.2 that we gathered was that if we know the multiplicities of our x-intercepts, depending on whether the multiplicity is even or odd, we know that whether or not the graph crosses the x-axis, that's when the multiplicity is even, or when, it touches the x-axis and bounces off, that's when the multiplicity is even, or crosses the x-axis, that's when the multiplicity is odd. The issue becomes, how do you find the x-intercepts by hand? So how does one go about figuring out x-intercepts? And that's where this 4.3 fits in. Polynomial division is a good tool to finding x-intercepts. All right, so let's talk about division, polynomial division here for a little bit. So you gotta think kind of old school division. You have you have your little house symbol, and you have what's called the dividend inside. You have the divisor, you have a quotient, and a remainder. Yeah? And in terms of polynomials, well, think about, you have a polynomial p of x that's being divided. So that polynomial p of x is called the dividend. It's being divided by this other polynomial called d of x. This other polynomial is called the divisor. And then you end up with what's called a quotient and a remainder. All of these are polynomials. And what's true is that the original polynomial, the dividend, is equal to the divisor times the quotient plus whatever remainder. Yeah? There are these two kind of important little, I guess we can call them theorems. And it's one of them is called the remainder theorem, and we'll practice it. Maybe right now the statement of it is a little bit vague, but we'll see the remainder theorem in action here in a second. If c is evaluated into our polynomial f of x, so if I figure out what is f of c, so f of c, that's the same thing as I would get as if I was to actually carry out the long division. The remainder would be equal to f of c. So let's see. So if a number c is substituted for x in the polynomial f of x, then we get f of c. And f of c is the remainder that would be obtained by dividing f of x by x minus c. So it turns out that f of c and the remainder end up being equal. And we'll see that. Another good point here is that if f of c equals 0, meaning that c is an x-intercept of your polynomial, then x minus c is a factor of f of x, meaning that the remainder of the division should be 0. Okay, now let's, there's this little business right here that says that we write our answer to a polynomial divided by a division in the form quotient plus remainder divided by divisor. Here what you gotta think is the following, that you have dividend equals quotient times divisor plus remainder. And now imagine, so this is a little equation that says that the dividend equals the quotient times the divisor plus whatever remainder. And now imagine that we divide everything by the divisor. So then I have dividend over divisor equals quotient plus remainder over divisor. That's what this little thing is talking about. Quotient plus remainder over divisor. Quotient plus remainder over divisor is just, we just end up dividing everything by the divisor. But we'll get into that whenever we get to use that. Let's get into an exercise here. Our first exercise. So we're dividing 205 by 3. In a sense, what we're doing here is polynomial division. These are two polynomials, 205 and 3. They are polynomials. They're polynomials of degree 0. So let me do this division. So we're gonna set it up like this. Okay, and now I gotta think, okay, how many times does 3 fit into 20? That's 6 times. 6 times 3 is 18. And I have a remainder of 2, because you gotta do minus here. You gotta think 20. 20 minus 18, that's 2. Bring down our 5. Okay, so 25. How many times does 3 fit into 25? I think that would be 8. So that's 24. And I have a remainder of 1. Okay. So in this whole scenario, what we can say is that, well, the 3 is called our divisor. So our divisor, the 205 is our dividend. We have a remainder of 1. Remainder. And we have a quotient of 68. All right, and another thing that we can conclude here, another thing that we can conclude from all of this is the following, that 205, so my dividend is equal to my divisor times my quotient plus whatever remainder. Yeah, this is a good little tool. It's useful to sort of help you break down numbers. You can think of, okay, so a number is equal to some quotient times some divisor plus some remainder. All right, so what we've done here is polynomial division. It's just that our polynomials right now are of degree 0. Now let's up the ante a little bit. Let's increase the challenge level. Let's do polynomial division with a polynomial of degree 3 being divided by a polynomial of degree 1. All right, I'll show you the first example, and then on the other examples, you will do them on your own. You will try them on your own. So let's see. Let's do the long division first. All right, so let me set it up. So x minus 2, 4x to the third minus 3x squared plus x plus 7. Okay. Now let's begin the division process here. Let's see. So I have my dividend inside the little symbol. I have my divisor outside. Right now I'm gonna start thinking about forming the quotient. So let me form a quotient. So the first thing I gotta think to myself is something right here times x should give me 4x to the third. So something times x should give me 4x to the third. And by the way, here notice that I have written the dividend in descending order. 4x to the third minus 3x squared plus x plus 7. Always write your dividend and your divisor in descending order. Also, if let's say you were missing the quadratic term, let's say that you didn't have the x squared term, so you had x cubed and then you jumped directly to x, you should fill in the x squared term with a 0. So if you're missing, let's say, the linear term, the x, let's say it was just something 4x cubed minus 3x squared plus 7. So you're missing the x term, fill it in with a 0 and write things in descending order. Yeah, so do that anytime that you're setting up your long division. So right now I've set up my long division correctly and I'm gonna start the process of division. So I thought to myself, somewhere over here with this little dark dot is something times x should result in 4x cubed. And I think that something is going to be 4x squared. So let's write a 4x squared up there. So this becomes 4x squared. Okay, so 4x squared times x, that's 4x cubed. And then 4x squared times negative 2, that's negative 8x squared. And then I'm going to say minus here. All right, so be careful with your signs. Here we're going to subtract this row minus this row, this upper two terms minus these two terms. So 4x to the third minus 4x to the third, well, that's 0. And then negative 3x squared minus negative 8x squared. So negative 3x squared plus 8x squared, that's positive 5x squared. And then I'm going to bring down this x. So that was the first step in trying to form my quotient. Now next step in trying to form my quotient, I gotta think something times x should give me 5x squared. So something times x should result in 5x squared. And I think my option there is 5x. So I'm gonna say plus 5x. So 5x times x, that's 5x squared. And 5x times negative 2, that would be negative 10x. And then I'm going to subtract. Okay? So what happened here is I said 5x times x, that's how I ended up with 5x squared, and 5x times negative 2, that's how I end up with this negative 10x. And now I gotta subtract these two terms minus these two terms that I generated. So 5x squared minus 5x squared, that's 0. X minus negative 10x, well, that's like saying x plus 10x, so that would be plus 11x. And then I'll bring down this 7. Alright, so the last turn of forming a quotient here. Something times x should give me 11x. And while I think I have no option other than 11 here, plus 11. So 11 times x is 11x. And then 11 times negative 2, that would be negative 22. Okay, and I'm going to do minus right there. Let's see what we get as our remainder. So 11x minus 11x, so that's 0. And then 7 minus negative 22. Well, that's the same thing as saying 7 plus 22. So that would be 29. Alright, so what we can say now is that x minus 2, so I guess some conclusions that we can kind of draw here is the following, that since the remainder is not 0, so since the remainder is not 0, then that means that x minus 2 is not a factor. Is not a factor. And it's not a factor of the third degree polynomial up here. Let me over here just let me call this third degree polynomial f of x, just to give it a name. So I'm gonna say 4x to the third minus 3x squared plus x plus 7. All right. So I am naming this polynomial f of x, and what we said here is that since the remainder is not equal to 0, our remainder is 29, then that means that x minus 2 is not a factor of f of x. So x minus 2 is not a factor of f of x. Which also means that 2 is, or rather 2 comma 0 is not an x-intercept. So 2 comma 0 not an x-intercept. That's the thing that we're kind of conclude right now. So 2 comma 0 is not an x-intercept, which means that x minus 2 is not a factor of my polynomial, because the remainder is not 0. So that's one thing I can conclude. Another thing to kind of notice here is, let me point out the remainder theorem. So the remainder theorem says the following. Let's think about what is f of 2. What would be f of 2? And let me just kind of use my calculator real quickly to compute f of 2. Alright, let's see. So what is f of 2? And I think I had already computed it using my calculator. So look, if I replace all of my x's with 2, that would be 4 times 2 to the third. So that's 4 times 8. So 4 times 8 minus 3 times 4, because 2 squared is 4. So minus 3 times 4 plus 2 plus 2 plus 7, and the result is 29, which is the same thing as our remainder. Yeah, so f of 2 happens to be 29. And so then right here we had our remainder. And the remainder theorem is telling us, that's why it's called the remainder theorem, that if we were to just evaluate our polynomial at 2, we get the same thing as if we had done division of the polynomial by x minus 2. The remainder is the same. Yeah, so keep this in mind. All right, so this is long division. Long division requires that we use all of our x's and powers of x's and whatnot. Let's do synthetic division now. Let's do the same problem using synthetic division. The thing about synthetic division here, what it says in this little parenthesis, is that it only works for linear divisors. So remember, the 4x cubed minus 3x squared, the third degree polynomial, that's called our dividend. The other one is called our divisor. And this is a linear divisor. Its exponent is 1. So let's see. I'm going to set up the synthetic division. The way you set up synthetic division is like this. So you draw kind of your little house again. Sometimes it's drawn like this. Other people draw it like this. It doesn't matter. I'll do it both ways. I'll do it both ways simultaneously. So I don't know. Pick your flavor. And then inside, you're going to put the coefficients in descending order of your dividend. So 4, -3, 1, 7. 4, -3, 1, 7. I don't know if you've seen this before. Sometimes this little house remains the same. Sometimes this little symbol is turned upside down. It doesn't matter. It's the same thing. So that's a 1. Okay. And now what goes so that's the dividend. Now for the divisor, well, the divisor has to be linear. Turns out that synthetic division actually does work for non-linear divisors, but it's more messy. You can look up a YouTube video. Just Google something like synthetic division with non-linear divisors, and you'll see several videos that help you do that. It's not that difficult. It's actually very similar. But right now we're gonna just use linear divisors for synthetic division. So the divisor, the way I'm gonna write the divisor, you might think, oh, it's gonna be the coefficients of my divisor, so 1 and -2, but turns out no, it's just +2. Yeah, and then there's this business of drawing this line down here. So by the way, I mean, I'm doing this division here kind of simultaneously. We're gonna end up with the same thing. Just notice that this 2 came from the fact that this was x minus 2, so I have to change the sign. So if I had something like x plus 3, this would have been -3. Yeah, so keep that in mind when dealing with synthetic division. All right, and then the first thing you gotta do is I'm going to drop down this 4 right there. All right, so this becomes 4. And then I'm gonna think to myself, 2 times 4, that's 8. And I'm going to write 8 right here. And then, see, with long division, we were subtracting. It was the top row minus the bottom row. Now we're just going to add -3 plus 8. -3 plus 8. So that's going to be 5. Same thing over here. This would be 8, and this would be 5. And now you got to think. 2 times 5. 2 times 5 is 10. So I'll put a 10 right here. And then 1 plus 10, I guess is, it's 11. Same thing over here. 10, this becomes an 11. Okay, and then 2 times 11, I guess that's 22. 22. And then 7 plus 22, I guess that's 29. 29. Okay, and so my remainder, this is my remainder. This is the remainder. This other part right here, this is my quotient. Yeah, and so then think about the quotient that we got earlier with long division. The quotient was 4x squared plus 5x plus 11. Well, that's exactly the coefficients here. 4x squared plus 5x plus 11. And our remainder was 29. Yeah, so this is our quotient up here with long division. This is a quotient with long division. Same thing over here. This is the quotient, and this is the remainder. Yeah. All right. So I think synthetic division eventually just makes your life a little bit easier. It makes these divisions a little bit easier. The one drawback of synthetic division, at least at this point, is that your divisor should be linear and that you have to change the sign. Keep that in mind. So that is the one drawback, because what if my divisor is not linear? What if I'm dividing this third degree polynomial divided by some second degree polynomial? How do I do synthetic division then? Turns out that long division works for any type of divisor. Long division works for any type of divisor. A third degree polynomial divided by a third degree polynomial, you can use long division. Synthetic division right now, it's only going to work for us for linear divisors, although it also works for non-linear divisors as well. You just gotta look that up on your own. Okay, good. So let's see. Let's think about the next problems here. Sorry, I kind of scribbled a little bit on top of it. So this next problem is you want to determine if x plus 1 and x minus 3 are factors of this polynomial. So in order for them to be factors, that would mean that the remainders should be 0. Yeah? Or, I mean, and right now practice with division. So practice your long division, practice your synthetic division, because another way to answer this question is negative 1 and is positive 3. Are negative 1 and positive 3 zeros, x-intercepts of this polynomial? That's another way to answer the question. So pause the video and see if x plus 1 and x minus 3 are factors of this polynomial. Alright, so hopefully you got a chance to practice here with your long division and your synthetic division. I'm going to just do one long division. I'm just going to do, I don't know, let's say x plus 1. So I'm going to do, I'll say, this was part of our previous problem. Let me use, yeah, so I'm going to do x plus 1 divides, let me make my little symbol a little bit smaller. So x to the third plus 2x to the second minus 5x minus 6. So let's see if x plus 1 is a factor of this polynomial. So let me go ahead and do this long division. So I think this is going to be x squared. So then I have x cubed plus x squared. Then I do minus. So this is 0. And this is 2x squared minus x squared. So that's plus x squared. Bring down my negative 5x. And then I gotta think, something times x is x squared. Well, I think that's just going to be plus x. So x times x is x squared. X times 1, well, that's plus x. And we're gonna say minus, so that's 0. And negative 5x minus x, that's negative 6x. Bring down my negative 6. Okay, and then something times x should give me negative 6x. So negative 6 times x, that's negative 6x. And then negative 6 times positive 1, that would be negative 6. And then if we do minus, we have 0. So then that means that x plus 1 is a factor. Yeah, so x plus 1 is a factor. Now I could do the x minus 3. I could check if x minus 3 is a factor in the same way. And if the remainder is 0, then I can conclude that x minus 3 is also a factor. I'm going to leave that up to you. I'm going to leave that, so if you want to practice with more long division, check and see if x minus 3 is a factor and see if your remainder is 0. So what I'm going to do over here just to practice synthetic division as well is I will set up the synthetic division for this for x minus 3. So the synthetic division is going to look something like this. So let me write down my dividend first. So 1, 2, -5, and -6. That is my dividend. Those are the coefficients of my dividend. And now I am going to test x minus 3. I want to know if x minus 3 is a factor. So the divisor is outside, goes outside, and we said that we have to change the sign. So my divisor right now is going to say just 3. Yeah? Alright, so let me carry out this, this synthetic division. So we drop this 1. So here I have a 1. 3 times 1 is 3. And then 2 plus 3, I guess that would be 5. 3 times 5, that's 15. -5 plus 15, that's 10. And 3 times 10 is 30. -6 plus 30 is 24. So this is my quotient. This is my remainder. Even if you did long division, your remainder should have been 24. Or another way to think about it is that f of 3 is equal to 24. That's another way to kind of think about it. If I was to replace 3 everywhere in this polynomial, I should get 24. So I guess what we can conclude is that x minus 3 is not a factor. Why isn't it a factor? Because our remainder is non-zero. Okay, so hopefully we agree on these answers, and hopefully you get a chance to practice a little bit with long division and synthetic division. Let's move on to the next example. All right, so they give us a polynomial, x cubed minus 8. They gave us a divisor. We already know that this is a divisor, x plus 2. So since it is a divisor, that means that the remainder, so if I divide p of x by d of x, what should the remainder be? If I already know that this is a divisor, the remainder should be 0. So they gave us these two polynomials, x cubed and this linear polynomial x plus 2. They want us to find the quotient and the remainder when p of x is divided by d of x. And then we gotta express p of x in the form d of x times divisor times quotient plus remainder. So pause the video. What I can tell you right now, what the freebie here is that r of x is 0. That's what I know. But what we do not know is what the quotient is. So pause the video, do the division, and see if we come up with the same quotient. Okay, so hopefully you got a chance to try this. Let's set this up. I'm gonna play with synthetic division, although we could have played with long division as well. It doesn't matter. I'm gonna use synthetic division. So I'm gonna use synthetic division. All right, so let's see. I'm gonna set it up. So first I'm gonna have to write down the dividend, the thing that's being divided, and that's the x cubed minus 8. And if you notice here, I'm missing a quadratic term. I'm missing the x squared, and I'm also missing the linear term. I'm missing the thing that only has x's. So I'm gonna have to fill them in with zeros. So right now this is going to look like this. 1. The 1 is because that's the coefficient of x cubed. There's a 1 in front. 1, and then 0, 0, and -8. So that's how you should have. The same thing is true about long division. If you were setting up your long division, you would have x cubed plus 0x squared plus 0x minus 8. So be careful with that. Now the divisor. The divisor is what goes out here. Right now my divisor is x minus 2. Sorry, x plus 2, x plus 2. So that means that over here with the synthetic division, I'm going to set it up like this. This is going to be -2. So this is how the synthetic division setup goes. The long division, I'm just gonna set up the division. I'm not gonna carry it out. So for long division, you would have the following. You would have x plus 2 outside as your divisor, and then as your dividend, you would have x cubed plus 0x squared plus 0x minus 8. Yeah? It doesn't matter how you go about it. If you like synthetic division better, then go with synthetic division. If you like long division, then do long division. Right now, I'm going to do synthetic division. So I've set up my synthetic division. Let me go through the process. So the 1 comes down. Negative 2 times 1, that's negative 2. 0 plus negative 2, well, that's negative 2. Negative 2 times negative 2, that would be 4. 0 plus 4 is 4. And negative 2 times 4, that would be negative 8. And negative 8 plus negative 8, that would be negative 16. So something's wrong here. Something is wrong here. Let's see. Let's just be careful with our signs. So the 1 came down. Negative 2 times 1, well, that's negative 2. 0 plus negative 2, that's negative 2. Negative 2 times negative 2, that would be 4. 0 plus 4. 0 plus 4 is 4. And then negative 2 times 4 is negative 8. Okay, well, no, there's nothing wrong. There's nothing wrong. Here is, that's negative 16. I think earlier I was telling you that the remainder is going to be 0. But that's not true, because, I mean, we were just told that it's some divisor, x plus 2. But we do not know if it divides evenly. So I guess our remainder is non-zero. So our remainder is negative 16. So my quotient, this is my quotient. This is my remainder. And I can think of the quotient as the following polynomial. X squared minus 2x plus 4. Yeah? So right now, the synthetic division only gives me the coefficients. And also, in order to know if it's x squared or x cubed, think about the dividend. The thing that goes inside my little house. That was of degree 3. So then the quotient should be 1 degree smaller. So this quotient should be of degree 2. All right. So we should have gotten the same thing with long division. And right now, this last part, I'm supposed to express p of x in the form divisor times quotient plus remainder. All right, so then let's do that. So let me do that over here. So we have that p of x is supposed to be equal to my divisor times some quotient plus some remainder. Okay, well, in our particular case, that means the following, that x cubed minus 8 equals my divisor. My divisor is x plus 2 times the quotient. The quotient is x squared minus 2x plus 4. And then minus 16. Minus or plus the remainder. All right, so hopefully we agree on that. And again, I guess we could also verify. We could actually carry out this multiplication. X times x squared, x times negative 2x, x times 4, 2 times x squared, 2 times negative 4x, 2 times 4, and then see what we get, minus 16, and we should get x cubed minus 8. All right, let's try the next one. Let's try actually these two next examples here. So determine whether or not 5 is a 0 of this polynomial, and use either long division or synthetic division to figure it out. And then on the next example, use synthetic division. So here you gotta use synthetic division and this function to find the following. Find the quotient and remainder of this division. So pause the video and try these two problems on your own. Okay, hopefully you got a chance to try them and you have some answers here. Let's see. So let's address the first problem here. So I want to determine is 5 a 0 of g of x? Okay, in order to test that, I'm going to do the following. So right now I'm dealing with positive 5. That means x minus 5. And then I'm going to have to write my dividend. That's going to be x to the 4th plus 0x to the 3rd minus 26x squared plus 0x plus 25. That's how you should have set up the long division. This is, if you're going to answer this question to determine whether 5 is a 0 of my polynomial g of x, then your divisor is going to be x minus 5, and your polynomial is x to the 4th plus 0x cubed minus 26x squared plus 0x plus 25. Remember that if you're missing any terms, you gotta fill them in with 0. Okay, now let me set up the synthetic division. To set up the synthetic division, I would do, well, something similar. I would do 1, 0, negative 26, 0, and 25. And outside here, my divisor, in this case, it would just be 5. Yeah? So let's see. It doesn't matter now which route we choose. We could play with the long division, we could play with the synthetic division. It doesn't matter. Right now the question is asking us to determine if 5 is a 0. So if it is, so if 5 is a 0 of g of x, that means that the remainder at the end of the division should be 0. So let's see. Let's test it. I'm going to play with the synthetic division because I think it's a little bit easier to handle. But if you want to practice with long division, by all means, do it. So we said that we're going to drop this 1. So we have 1. 5 times 1 is 5. 0 plus 5, well, that's 5. 5 times 5 is 25. And negative 26 plus 25, that's negative 1. So negative 1. Negative 1. 5 times negative 1, well, that's negative 5. 0 plus negative 5, that's negative 5. And then 5 times negative 5 is negative 25. And I end up with that. So remember, this is our quotient. This is our quotient. And this is my remainder. So right now we can definitely conclude, so 5 is a 0 of g of x, which means that, it also means that x minus 5 is a factor of g of x. These two things are equivalent. To be a 0 of g of x is the same thing as x minus 5 being a factor of g of x. So if we had actually carried out the long division, we would have gone through some steps and eventually we would have ended up with 0. That should have been a remainder. And up here in the quotient, we should have ended up with what? X cubed, x to the 3rd plus 5x squared minus x minus 5. Yeah, that's what I gathered. That's what my quotient is telling me. X to the 3rd, 5x squared minus x minus 5. All right, so hopefully we agree on that. So 5 is a 0. 5 is a 0 of g of x. So let's try this next one. Oh, this next one had some parts. That's okay. So let's see. The first part. Hopefully you have answers for the first part. The first part just asks us, find the quotient and the remainder of this division. And they want us to use synthetic division. So we're going to do the following. Let me set up the synthetic division. And that's, I don't like, yeah, there we go, that one's better. So 2, remember I have to change the sign whenever I'm dealing with synthetic division. So 2, this becomes 2, and then 0, because I don't have a cubic term, and then 1, and then negative 10, and then 1. That's how I'm going to set up my synthetic division. So 2, and then the dividend is 2, 0, 1, negative 10, 1. Let me go through the process here. So this 2 comes down, that becomes 4. So that's just 4. And then this is 8. 1 plus 8 is 9. That would be 18. 10, negative 10 plus 18 is 8. This would be 16. So that's 17. Let me just double check my work here. The 2 just came down, and then 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 1 plus 8 is 9. 2 times 9 is 18. Negative 10 plus 18 is 8. 2 times 8 is 16. 1 plus 16 is 17. Good. So that's my quotient. This is my remainder. Okay, so we can say that the quotient is going to be 2x to the third plus 4x squared plus 9x plus 8, and my remainder I guess is just 17. Okay, next one. I gotta figure out what is f of 3. And you might be thinking, oh well, that's easy, just plug in 3 into the polynomial, and that's true, we could do that. But let's try to take advantage of the remainder theorem. The remainder theorem says that f of 3 is equal to the remainder that I get if I divide my polynomial by 3. So let's set that up. So we're gonna say 3 outside, that's my divisor, and then I have 2, 0, 1, negative 10, 1. So let's go through this process again. So we said the 2 goes down here, 3 times 2 is 6, 0 plus 6, I guess it's 6, this is 12, so that's 13, that would be 39, so that's 39, negative 10 plus 39, that's 29, and then 3 times 29, that's what? So that's a 7, 87, I think so. 3 times 9 is 27, so 7 carry over 2, 3 times 2 is 6, and 2 is 8, okay, and then this would be 88. Okay, so then that means that f of 3 is equal to 88. Yeah? Good. All right, the last one. The last part. We want to determine whether or not 0 is a 0 of f of x. So we want to determine if the origin 0, 0 is an x-intercept of my polynomial. Okay, so similar process. So I'm just going to, so in order, if 0 is a 0 of f of x, that means that its remainder, after division should be 0. So let's kind of take advantage of this again. So I'm going to do synthetic division again, so it's going to be 0. And then I'm going to have, we said 2, 0, 1, negative 10, 1. So this 2 comes down, 0 times 2, well that's 0. 0 plus 0 is 0, 0 times 0 is 0. 1 plus 0 is 1. 0 times 1 is 1. Negative 10. Negative 10 plus 1, that's negative 9. And 0 times negative 9 is 0. And 1 plus 0 is 1. So right now, my remainder is 1. So I guess what we can conclude is that f of 0 happens to be 1. Which makes sense. If you look at the original polynomial, if you replace all of your x's with 0, well, all of these terms go to 0, and all you have left is this lonesome 1 right there. So f of 0 is 1, which means that I guess our conclusion is that 0 is not a 0 of f of x. All right, so that is it for this section, 4.3. Definitely this will come in, this is a good skill to have, long division, synthetic division of polynomials, and you'll definitely use it to graph further polynomials by hand. Okay, thank you and see you in the next section.